because we have a fourth degree polynomial here being equal to 0, this equation is going to have 4 solutions. So to get started in finding those, we need to make a list of our possible rational solutions. And those rational solutions are going to come from a combination of a factor of 13, the constant term, over a factor of 1, the leading coefficient. So the only factors of 1 are 1, and so the denominator is always 1. The factors of 13 are plus or minus 1 and plus or minus 13. So we only have 4 possible rational solutions here. And so we can go ahead and start checking those using synthetic division. So we set up the rest of our coefficients. And we're looking for a remainder of 0. If the remainder is 0, then we have found one of the solutions. If it's not, then we need to keep looking through the rest of that list. And our plugging in a 1 there in the box gave us a remainder of 0. So that is one of our solutions. So I'll keep track of those down here. So far we have x equals 1. Again, we're looking for 4 solutions. Now we have no guarantee that all 4 of them come from this list. In fact, it's likely that some of them do not. So we're using this list hoping to get down to a quadratic polynomial. Then we could solve that using the quadratic formula if necessary. So what we've done so far, we started with a 4th degree polynomial. So by doing this division now, these numbers would represent the coefficients on an x cubed or a 3rd degree polynomial. So my other 3 solutions are going to come from essentially setting that polynomial equal to 0, that 1x cubed minus 5x squared plus 17x minus 13. And so that means as I continue to check numbers in my list of possible solutions here, I'm going to use these new numbers as my coefficients there on the top row. That way when I find another one that works and divide it out, I will be down to having a quadratic. So if I start over with my 4th degree coefficients again and find another solution, then my numbers here in the bottom row would still only represent the coefficients on a 3rd degree polynomial. So I wouldn't be able to use the quadratic formula. So we need to go ahead and use these new values here in our top row. So it is possible that 1 is a 0 of multiplicity greater than 1, so we should check 1 again using these new values just to make sure that we don't miss it. And it turns out that gives us a remainder of 0 again. So 1 would be a solution or a 0 of multiplicity at least 2. So as far as in our final answer down here, I don't need to list it twice because it's just asking me to solve the equation. So 1 is something I can plug in for x and get a true statement. I don't need to put it in there twice. And now we have these coefficients down here representing the coefficients on a quadratic polynomial. That's 1x squared minus 4x plus 13 equals 0. So we can solve that either by factoring or the quadratic formula. That cannot be factored, so we need to go ahead and use the quadratic formula. So we get x equals negative b, so that's positive 4, plus or minus the square root of b squared would be 16, minus 4 times 1 times 13 over 2a, it's 2 times 1. So inside that square root there we get 16 minus 52, so that's a negative 36. And the square root of a negative we need to rewrite in terms of I. And then square root of 36, that's 6, so we have 4 plus or minus 6i over 2. So I can divide each of those two terms up top by 2 and get 4 divided by 2, that's 2, plus or minus 6i divided by 2 would be 3i. So there's our other 2 solutions there. It would be 2 plus 3i and 2 minus 3i. So I mentioned here that we were expecting 4 solutions. Essentially we have accounted for all 4 of them. So 2 minus 3i, that's 1. 2 plus 3i, that's 2 solutions. X equals 1, that's 3 solutions, but we got x equals 1 there, multiplicity 2. So that accounts for all 4 of them.